Hi everyone, welcome back. I hope that by experimenting with that applet you were able to see what the values of A, B, and C do to the graphs. So let's now figure out how A, B, and C relate to the three words that we discussed: amplitude, period, and midline. So we're working with a function that is either written as A sine bt plus C or A cosine bt plus C. Let's put the plus C in the right place. Good catch. And I hope some of you got that at home. As we said, we're not going to do any shifts on the inside, any horizontal shifts. So the amplitude is 1/2 the vertical distance from the highest point on the graph to the lowest point on the graph. So normally the graph of sine and cosine go between -1 and 1, so a total vertical distance of 2, but we say the amplitude is 1. It's half that vertical distance. So in the applet, which of these three letters, A, B, or C, was it that determined the amplitude? I hope you figured out that it was A. We learned last week that multiplying by A on the outside stretches the graph vertically. So we can say that the amplitude is A, but we have to be a little bit careful because, for example, if I do 3 sine of t, the graph gets stretched vertically by a factor of 3, now goes from a low of -3 to a high of 3, total distance of 6, so the amplitude should be half of that of 3. But what if I do -3 sine of t? That also stretches the graph by a factor of 3, but also flips it around the t-axis. We still want the amplitude of that to be 3. So I don't want to say the amplitude of that is A, because then that would give me a negative amplitude. So how are we going to fix that? Whether I multiply by 3 or -3, I still want an amplitude to be 3. The way to fix that is to say that the amplitude is the absolute value of A. This is the official math definition of the period. The way that you can think about it is just the shortest length of time it takes to repeat. But in order for us to make it really nice and mathy, this is what we need to say. We say the period P is the smallest positive P. You've got to say the smallest because you might think that the graph of sine and cosine repeat themselves every 2 pi radians, or 360 degrees. But they also repeat themselves every 4 pi, and every 6 pi, and every 8 pi, and every 22 pi. And therefore, everybody on the planet could have their own different period length for sine and cosine. We want it to be the smallest one, so that's we want it to be 2 pi. And the real way to say that you repeat yourself is that you're saying that the graph of f of t plus p is the same as the graph of f of t. Because this plus p, as we learned last week, does a horizontal shift p units to the left. So it says when I do a horizontal shift by p units, I get exactly the same graph back. That's what it means to repeat yourself every p units. So the smallest value of that is what we're going to call the period. So normally sine and cosine have a period of 2 pi. I hope you figured out that it was the value of b that made themselves repeat themselves either more rapidly or less rapidly. The b, as we discussed last week, squeezes the graph by a factor of b. So for example, if you do sine of 2 pi, it squeezes the graph by a factor of 2, meaning it is now repeating itself twice as fast. So instead of having a period of 2 pi, the period is cut in half to just pi. So the period is given by 2 pi divided by b. Again, so for example, if b had been 4, you squeeze the graph by a factor of 4, so the period, which used to be 2 pi, is now a quarter of that, or 2 pi over 4. We do have to be careful about the same thing we did with the amplitude, though, because if I do a b equaling, say, -4, then that squeezes the graph by a factor of 4 and flips it around the vertical axis. But we don't want to have a negative period, so for the same reason that we put absolute values there, we're going to have to put absolute values there. So the period is going to be 2 pi over b. So that's, as you make b bigger, the period gets smaller. And finally, the midline, which is the average of the maximum y value and the minimum y value. So normally the average of the maximum and the minimum for sine and cosine is just 0. The line y equals 0 goes right through the middle of them. And I hope you figured out from the applet that it is the c that affects this. So the midline is simply the line y equals c, because that c shifts the graph up or down by c units. So now that we've got these three words defined, let's try to put them into practice, as we always like to do in this class, with a word problem. So many things in real life, as we discussed, behave sinusoidally, repetitively, periodically. One thing that does this is the height of the tide in a certain harbor that we're talking about here. It's a sinusoidal function. It goes from a high of 18 feet to a low of 10 feet. And the period is 12 hours. And yes, mariners, I know that the tide does not really go in and out exactly twice a day. It should be more like 12.4 or something. We're going to choose 12 just to make it a little easier to work with the numbers. Or you can pretend that it's on a different planet. A period of 12 hours, and at time 0, we're at 18 feet. We want to write a formula for h of t, meaning we're going to have to choose the values of a, b, and c, and whether to use sine or cosine or negative cosine. Those are our 4 choices. So the amplitude is supposed to be 1/2 the vertical distance from the maximum to the minimum. So that's a distance from 18 to 10, so that's 8 feet. So if you wanted to write that out as a formula, 18 minus 10 over 2, which is 4. So that's what our absolute value of a should be. So a is going to end up being 4 or negative 4. The period, we were told that the period is 12 hours. And we figured out over there that that's 2 pi over the absolute value of b. And if you solve that for b, you get pi over 6. Or 2 pi over 12. You don't have to simplify if you don't want to. The midline is supposed to be y equals the average of the max and min y values. So the highest y value is 18, the lowest is 10. So halfway between those should be 14. And again, if you want to write that out as a formula, you can say 18 plus 10 over 2, that's 14. So that's our value for c. So now we figured out what a, b, and c should all equal. And the question left is, should we be using sine or cosine or negative cosine? Because we're promising you'll never have to do any horizontal shifts in this class. You're welcome to, but you don't need to. The key here is that we know that at time 0, the graph, the function, is at its highest point, 18. So you can look back now at your graphs of sine and cosine and see which one of those starts off at the highest value. And you should discover that that's cosine. Sine of 0 is 0. So sine is starting at the middle. Cosine is starting at the highest value. So that's why we're going to use cosine. So we have our function h of t is, for a, we're going to put in 4. Cosine, for b, we decided it would be pi over 6. And for c, 14. And you might all be screaming something right now, and I hope you are. That's good. I see a lot of people go to all this work on the exam or the homework and write this answer, and it pains me to take off half a point, because what's missing? What's missing is the variable. There's no t. So in fact, this is a very complicated way of writing a formula for a horizontal line. This doesn't change as t changes. So we have to put that variable t in there. And now we have a function that really is oscillating. So let's just go back one more time and discuss how we chose to do cosine. At time 0, the graph was at its high point, and of our sine and cosine graphs, the one that does that is cosine. If at time 0 we would have been at the low point, that means we took the cosine graph and we flipped it around the t-axis, the horizontal axis. So if at time 0 you were at the low point, we would want to use negative cosine. So it would have been negative 4 cosine t. If at time 0 we were at the midline, then we would know it was either sine or negative sine. But if we just knew that we were at the midline, we wouldn't know which one of them it was. You'll notice that the graph of sine starts at the middle value and starts going upward, whereas negative sine starts at the middle going downward. So if, for example, we had been told that at time 0 it was at the midline of 14 feet and rising, then we would know to use positive sign. If we had been at 14 feet at time 0 and falling, then we would know to use negative sign. That's how you choose which of the 4 ones to use. So we defined the functions on the unit circle, sine and cosine, at the start of this unit. But we mentioned that you might have learned them on triangles, learning like ratio of opposite over adjacent and things like that. We want to make sure that our definitions of sine and cosine on the unit circle match those given on triangles. So I've called this triangle trigonometry. That seems a little redundant, but it's meant to be as contrasted with unit circle trigonometry. So when you learn sine and cosine, when you learn sine on a triangle, I hope they taught you that it was opposite over hypotenuse. There's some mnemonic for remembering that, which you might know. So in this case, if my angle here is theta, then, and what I've drawn here is the unit circle, and I had to draw the unit circle either bigger or smaller than the original triangle. It doesn't matter which one you draw, but I had to draw it one way. So I drew it smaller than the big triangle. So sine is opposite over hypotenuse. So it's the length BC over the length OB. Somehow we're supposed to know that we're supposed to show that that's going to be the same as just the y value on the unit circle. So the y value on the unit circle, because that was how we defined it there, that's this y value, which is this distance here. So how come this y value, this distance, is the same as the ratio of opposite BC to hypotenuse OB? And it's because we have a similar triangle here. This big triangle is similar to, meaning shares the same angles with, this small triangle. And the important thing to know about similar triangles is that their sides are in proportion. So the opposite side over the hypotenuse of the big triangle is the same as the opposite side over the hypotenuse of the small triangle. The opposite side of the small triangle is y. And because we're on the unit circle, what is this distance here? This is a radius of the unit circle, and the radius of the unit circle is 1. So that's y over 1, which is y. Check. That's what we were hoping we would get. So whether you do your sine as opposite over hypotenuse on a triangle, maybe the first way you learned what sine was, or you do it on the unit circle with our definition of the y value, you get the same answer, which is good. We don't want to define a function and get two different answers on two different shapes. That's no good. Mathematicians are very particular about that. Cosine is the adjacent side over the hypotenuse. And remember, here we're hoping that this is going to work out to be the x value. So on my big triangle, adjacent is OC, hypotenuse is still OB. But again, because these are similar triangles, the ratio of the adjacent to the hypotenuse on the big triangle should be the same as the ratio of the adjacent, which is the letter x, right? This distance here is simply the x distance, to the hypotenuse. But again, the hypotenuse is 1. So whether you do adjacent over hypotenuse or simply the x value on a unit circle, cosine of theta gives you the same thing. I know I will sleep better tonight. I hope you will too. There are 4 more trig functions that come up that we should know. We will definitely be seeing tangent and secant again. We probably won't be seeing these, but I'm going to put them in there for the sake of completeness anyway. Tangent is sine of theta over cosine of theta. Secant is 1 over cosine theta. Cosecant is 1 over sine of theta. Cotangent is 1 over tangent of theta. So these are good to know. It saves us from having to write fractions. We can just write these functions instead. We'll be doing that when we do some calculus in the weeks to come. The last thing I want to say before we get to inverse trigonometry is, where do these names come from? So the name sine was the first one. That comes through us. It's been messed up through all these different passages through languages, from Arabic and Latin, originally from a Sanskrit word which meant half of a chord on a circle. That came to us and it means sine. So we just have to take that as a given. Then there's cosine. So where have you seen the word co in geometry class? I hope that if you've seen it, you might not have. It's fine if you haven't. But it means complementary. We see the word co as short for complementary in geometry. Complementary angles are angles that add up to 90 degrees. So the cosine is the sine of the complementary angle. That's where the word co comes from. The letters co come from in all of these. Cosine, cosecant, cotangent. The sine of the complementary angle. Meaning, for example, that the cosine of a 60-degree angle is the same as the sine of a 30-degree angle. The cosine of a 2-degree angle is the sine of an 88-degree angle. I know I'm using degrees. We're going to use radians, but usually we see them in degrees in geometry class. And then two more. These are the ones I like the most. Tangent comes from the Latin word tangere, or tangere, which means to touch. So when we draw this unit circle here, and I've got my angle theta, and I draw a line out here that this is the unit circle, just grazes, just touches the unit circle right down here at our starting angle. This length right here that cuts, where this line cuts through that line, is going to be the tangent of that angle. And let's see why we can see that. Tangent, we know, as we defined over here, is sine over cosine. So that should end up being opposite over adjacent on a triangle. So opposite of this is BC, and adjacent is OC. But because this is the unit circle, how long is this line OC? That's just 1, so that becomes just BC. This whole thing, by the way, is just for your own historical information, for fun, if you want to understand where these words come from. It's not going to be on the test or anything like that, but I know some people are interested in this. So tangent comes from the Latin word for to touch. So when I draw a line that just grazes the unit circle over here, that's how I get the tangent length. Secant comes from the Latin word for to cut. So if I draw this line and I extend it out here, cutting through, now remember, secant is 1 over cosine. Cosine is adjacent over hypotenuse. So secant should be hypotenuse over adjacent. So if I want the secant of this angle, I should be taking the hypotenuse, OB, over the adjacent side, OC. But just as up here, OC, that's 1 radius of the unit circle. So that's just 1. So that just becomes OB. So the part where we cut through here, this length, is the secant of that angle. I hope you enjoyed that as much as I did. If you want to understand where these words come from, this is where it is. And after all of that, we have a check your understanding on trig functions. So please give that a try and then come back for the next video.